গুড মর্নিং স্যার।
গুড মর্নিং।
স্যার বলছি আগের দিনের এই পার্টটা একবার রিপিট করবেন, আমার ওই লাস্ট দিকে ডিসকানেক্ট হয়ে গেছিল।
আগের দিনের পার্টটা
ওই যে আইডিয়াল ডিজায়ার্ড ফিল্টার রেসপন্স।
আইডিয়াল ডিজায়ার্ড ফিল্টার রেসপন্স। দাঁড়াও দেখছি।
Good morning, sir.
গুড মর্নিং। Okay. So last class what we are discussing that ideal desired filter response, right? Ideal desired filter response. This one.
হ্যাঁ এখান থেকে হ্যাঁ।
So ideal desired filter response, a low pass filter and low pass filter. Low pass filter actually passes low frequency, right? Low frequency. So low frequency means suppose 0 to omega c. This is the low frequency that will pass. But the negative counterpart of this equal to minus omega c to plus omega c. Therefore, if I say my range of vision minus pi to pi, since DTFT maximum frequency, digital frequency is 2 pi, right? So minus pi to pi is the interval of 2 pi. Now, if I say that 0 to omega c is the positive side, so negative side also replica of this will be 0 to minus omega c. So low pass filter will be having this kind of response. By definition of low pass filter, it will pass some low frequency up to the cutoff frequency. Beyond cutoff frequency, it will not pass. This is the ideal response for low pass filter. Is it okay?
Yes.
Now for high pass filter, it will pass certain frequency to some higher frequency, right? So I say omega c is the cutoff frequency, it will pass beyond omega c to say maximum frequency pi, and negative counterpart of this omega c to minus pi. But anyway, we will design the final response will be from 0 to pi only. So I mean 0 to pi, out of which 0 to omega c, it will be 0. But this is ideal in the sense this cutoff is very sharp, because immediately before omega c, filter response is ideally c. However, immediately after omega c, it becomes 0. In practical filters, that cannot happen, because if I want to have this, that means immediately before that it is 0, and immediately after the omega c it will be, immediately before that you will be having value c, immediately after that it is 0. This requires sharp cutoff. Sharp cutoff cannot be achieved by practical circuits, practical digital circuits or practical analog circuits. Therefore this is ideal, right? This is not practical. Practically you may have low pass filter something like this. You may have certain transition band, then pass band also not that much flat, like that.
Good morning, sir.
Good morning. So ideal cases means it will be 0 to omega c, it is passing, and immediately after omega c it will become 0. Similarly, high pass filter also like that. Omega c to pi it will be passing, and beyond pi by pi it will be 0. Now for band pass filter, it will be passing omega c1 to omega c2, this particular band, and negative counterpart of this is minus omega c1 to minus omega c2 to minus omega c1. Now this is also same thing, that sharp cutoff at omega c1, omega c2, right? So this is ideal. This is why it is written ideal. Again, for band stop filter, it will be passing all the bands between minus pi to pi, except omega c1 to omega c2, or minus omega c2 to minus omega c2. So this is the band it is not passing. That's why it is band stop filter. All right. Later part is this part. This part is okay. Or this part I shall I repeat this part?
স্যার দিস পার্ট অলসো
Sir, ওখানে পরের পেজটা একটু করুন।
এটা পরে পেজ। আচ্ছা।
হ্যাঁ।
This part, what I have said, that if I have hd of omega, then if I take the inverse, hd of omega is a continuous function of omega, and it is periodic with period 2 pi. Okay. Now if I find hd of n, then I can find for any value of n, we will get certain value of hd of n. For n equal to 0, n equal to 1, n equal to 2, n equal to 3, n equal to -1, -2, whatever value I can say, for every value, you will be having certain value of hd of n. Now, with respect to this, what I can say that hd of n is infinite, because all values of n, if I have non-zero value of hd of n, which means the nature of hd of n is infinite. However, we are trying to design a FIR filter, which is finite impulse response. If I want to have finite impulse response, then I have to make this infinite hd of n in a finite series. How do I do that? I have to multiply hd of n with some wn. Wn is known as window function. If we multiply this, then what happened? Whatever be the value for which wn exists, if I multiply these two, then those values will be existing where wn exists. When wn does not exist, in such a case, this product will also does not exist. Suppose n equal to 0 value is there, n equal to 0 value is there, this product will be multiplied, this will be multiplied, this will be multiplied. But when this is 0, beyond this particular point, then rest of the thing HDN having value. However, the product will not having the value. Therefore, this window function I am defining 0 to n minus 1 because this is having n number of samples. If I have n number of samples in the W of n, then I will write n equal to 0 to n minus 1. Then if we multiply these two, then multiplication is my impulse response of the filter. Then if we multiply these two, this becomes finite. Again, it will exist 0 to n minus 1, over which your Wn exists. If Wn does not exist, then product also will be 0. When Wn exists, product will exist, like that. Therefore, this is the window over which I am seeing the desired impulse response. Physically, the window over which I am seeing the hd of n, that is final, right? So this is why this is known as window function. This window function will be specified in the problem. If this window function is not specified, window function could have several kind of, it may be Hamming window, Hanning window, Blackman window, and rectangular window. There are many other windows exist, and different window function have different filter characteristics. We will learn this in due course, but at the time being, what we will learn, unless otherwise window is specified, always we will assume a rectangular window. And if specific window function is specified, then we have to use that particular window function. However, whatever be the nature of the window function, this will be multiplied with the desired impulse response hd of n, and this product will be a finite in nature, so that a FIR filter design can be carried out further. Okay. Now, once I achieved Hn, then I have to find the DTFT to find the frequency response. See, if I say filter design means two aspects is there. One is, first you have to design in time domain, and ultimately you have to show the frequency response so that it may look like a low pass filter in case of low pass filter design. Therefore, once you design the filter, then you have to find the frequency response of the filter. Unless you find the frequency response of the filter, then filter design is not complete. So two things. One, have to design in the time domain. Time domain you have to design means you have to assume ideal response. After assuming the ideal response, you have to find the inverse Fourier transform. Once you find inverse Fourier transform, then you have to multiply with the window function. Then you have to get the finite impulse response. Once you achieve the finite impulse response, then you have to find the Fourier transform. Fourier transform to find the frequency response of the filter or frequency domain description of the filter. And this frequency domain description has to be closer to your ideal response, considering the practical aspect as well. Your design has to have the practical aspect. You may not have the ideal aspect, but nature should be look like ideal. A low pass filter should not look like high pass filter. A high pass filter should not look like low pass filter. So nature should be look like a low pass filter. So that I have to ensure by means of frequency response. Now to find the frequency response,
স্যার স্টেপস গুলো আরেকবার বলুন।
স্টেপস গুলো যখন আচ্ছা স্টেপস গুলো হচ্ছে প্রথমে আইডিয়া ধরো সাপোজ ইউ হ্যাভ টু ডিজাইন এ লো পাস ফিল্টার, then first you have to do what? First you have to assume certain desired hd of what do you call omega, hd of e power j omega. That I have said that force I have given the response, four response, that ideal low pass, ideal high pass, ideal band pass, ideal band stop. With that you have now have desired response. Once you have desired response, then you can find hd of n, which is the inverse of your desired response. Once you find hd of n, then you have to multiply with appropriate window function, maybe given or maybe assuming rectangular window. Then rectangular window, if it is specified, then you will be specified number of sample to be taken. Number of sample means value of n. Suppose 7 sample, 5 sample, 10 sample, 11 sample, that sample will be given. Then you can find from that h of n. Okay. So while discussing filter design, I will discussing these steps in detail, not to worry about at this stage. Okay. So once you have the wn, that is multiplied by hd of n. So first step to assume hd of e power j omega, ideal response. Second step to find hd of n. Third step to assume appropriate window function or use appropriate window function, that is wn. Then multiply wn with hd of n, you will get hn. Once you get hn for your given samples, suppose 10 samples, so 0 to 9. Once you get hn, then you have to find the frequency response of the filter, h of e power j omega. Now h of e power j omega. Now h of e power j omega, h of omega equal to n equal to 0 to n minus 1, h of n e power minus j omega. This is the formulation for Fourier transform for n samples. In general, it is minus infinity to infinity. In general, h of e power j omega or h of omega, that is n equal to minus infinity. But considering the n samples, this is hn e power minus j omega. Now I have discussed that h of omega is nothing but plus or minus magnitude h of e power j omega into e power j alpha omega. Now in this step, what I have said, now we have to expand this e power minus j omega n, I am written cos of omega n minus j sin omega n, e power minus alpha omega, I have written cos of alpha omega, j sin alpha omega. Then if we take the ratio, then first what you have to do, first I have taken the real part and imaginary part, I have equated. Real part of imaginary part, if I equate, then I will get n equal to 0 to n minus 1, hn cos omega n equal to plus or minus h of e power j omega cos of alpha omega. Then if I equate the imaginary part, then I will get h of n sin omega n plus or minus h of e power j omega sin alpha omega. Now if I divide this, then I will get sin of alpha omega by cos of alpha omega. Divide this by this, then I will get h of n sin omega n, h of n cos omega n. Because sin will be top, cos will be bottom, or opposite also okay. Now if I cross multiply these two, then I will get h of n cos omega n, this sin of alpha omega, this is all right. Now what I am doing, I am writing n equal to 0 to n minus 1, h of n cos of omega n sin of alpha omega, then cos of alpha omega here, h of n sin omega n cos of alpha omega. Then I am written n equal to 0 to n minus 1, hn sin of alpha minus n into omega equal to 0. Okay. Now from this equation, what I have included? I have included finite nature of an infinite series. At the same times, I have included the linear phase characteristics. Linear phase characteristics is essential. Linear phase characteristics and constant amplitude, two things. So these two are essential to avoid amplitude and phase distortion during passband. That also I have said that if a signal is multiplied by some constant or shifted by some amount, that will not alter the basic characteristics of the signal. However, other way, if it is changes, then it will change the basic characteristics of the signal. Suppose if I have x of 2n or x of n, two signals are totally different. But if I say x of n or x of n minus 1, these two signals are not different in character. They may be shifted. If it is shifted right, I can shift back left. If it is multiplied by some constant, say 2, I can multiply by again half, so that I can get the amplitude of this signal as desired. Therefore, if a signal is multiplied by some constant and shifted by some amount, then this is not changing the basic characteristics of the signal. And this is desired. This is because filtering is a process by which we extract desired part of a signal. Desired part of a signal. This is the basic characteristics of a filter. Now, while extracting the desired part, it should not alter the desired path much. Suppose if signal is changed, signal phase is changed, then signal will be changed. That is not the desired. The desired part is whatever part we will extract, that part characteristic should not change, right? So that's why the linear phase and the constant amplitude is the criteria. If linear phase is not maintained, there will be phase distortion, and constant amplitude is not maintained, that will be amplitude distortion. You have learned these things in transmission line as well. Transmission line, you have learned these things, is not it? Transmission line, you have seen that primary constant of the line RLGC. You remember? There also amplitude and phase distortion. So amplitude and phase distortion will not be there. Then there will be some condition, R by L equal to G by C, something is there, no?
Yes. Yes.
So that is also a criteria to avoid amplitude and phase distortion. Is not it? So amplitude and phase distortion has to be avoided. That is, in the transmission line where you are transmitting the signal, during the transmission through the line, signal should not be changed, because transmission line, what is the purpose of transmission line? To carry out the signal from source to the load. You are trying to carry the signal from source to the load, but you don't want that while carrying the signal from source to load, signal gets changed. That is not the desired. Therefore, you have certain condition imposed over transmission line that will ensure no amplitude distortion, no phase distortion. Right? You have come into that thing. Similar situation.
বলছি যে বললেন তো কই অ্যামপ্লিটিউড বা ফেজে কোনো মানে যদি মাল্টিপ্লাই বা এখানে ফেজের যদি কোনো শিফটিং হয় তাহলে সেটা অল্টারনেট করে ঠিক করা যাবে, তাহলে এখানে মানে
হ্যাঁ অল্টারনেট করে
অরিজিনাল সিগন্যালে আনা যাবে যদি x অফ n মাইনাস
যদি শিফটিং হয়, শিফটিং হলে সেটা করা যাবে। ধরো একটা শিফট হয়ে গেল বেশি, তাহলে আমি আরেকটা অন্য শিফট করে আবার নিয়ে চলে আসতে পারবো। শিফটিং এসেনশিয়ালি হোয়াট? ডিলে। শিফটিংটাকে একটা ডিলে, তাহলে ডিলেটা কমাতে পারবো, তাই না? তাহলে
তাহলে
বলো,
তাহলে বলছেন ফেজ ডিস্টরশন থাকা চলবে না? মানে
ফেজ ডিস্টরশন থাকা চলবে না মানে হচ্ছে কি, যে ফেজ যদি ফেজটা হয় না, ফেজটা যদি লিনিয়ার ফাংশন না হয়, তাহলে ফেজ ডিস্টরশন হবে। ঠিক আছে? ফেজটা যদি লিনিয়ার ফাংশন হয় তাহলে ফেজ ডিস্টরশন হবে না। এখানে তোমরা যদি মনে থাকে, তোমরা যখন ইলেকট্রোম্যাগনেটিক্সে পড়েছিলে তখন মনে আছে ফেজ ভেলোসিটি, গ্রুপ ভেলোসিটি। তাহলে ফেজ ভেলোসিটিটা যদি ইন্ডিপেন্ডেন্ট অফ ওমেগা হয় তাহলে কি হবে, যে ফেজ ডিস্টরশন হবে না। তোমরা ওখানে ট্রান্সমিশন লাইনে পড়েছিলে ওটা? কখন হবে বলো তো ওটা? তখনই ওটা হবে যদি ওটা লিনিয়ার ফাংশন অফ ওমেগা হয়। লিনিয়ার ফাংশন অফ ওমেগা হয়। লিনিয়ার ফাংশন অফ ওমেগা না হলে কি হবে, ফেজ ভেলোসিটিটা উইল বি ফাংশন অফ ওমেগা, দেন ডিফারেন্ট ফ্রিকোয়েন্সি কম্পোনেন্ট উইল ট্রাভেল উইথ ডিফারেন্ট ভেলোসিটি, ফেজ ভেলোসিটি। সো দ্যাট উইল গিভ ইউ দ্য ফেজ ডিস্টরশন। ওকে, অতটা ডিটেলসে আমি যাইনি এখানে, ঠিক আছে? অনলি থিং আমি বলেছি যেটা, সেটা হলো যে if I have a linear phase characteristics, then phase distortion will not be there. Agreed? বোঝা গেল? এবার যদি তোমরা প্রশ্ন করো why linear phase characteristics হলে phase distortion হবে না, তার অ্যান্সার হচ্ছে যে linear phase characteristics হলে phase velocity will be a constant and that will not be a function of omega, therefore there will be no phase distortion. Okay, now so if you have a linear phase, at the same time in this equation what I have done, we have included both finite nature at the same time the linear phase At the same time, we have included the constant amplitude characteristics because magnitude h of j omega. This is constant. And this is, I have denoted while giving this magnitude h of j omega is some constant c. C is some constant value, right? So this will be this will be ensuring that edge distortion and finite nature, this together is this formulation. This is the formulation. Now I have to find one solution of this. Now we have to find one solution of this. Now if we observe that impulse response h of n n equal to 0 to n minus 1, this is not equal to 0. This particular h of n, it is 0 hobe na. If this becomes 0, then there is no filter. Is that it? So hn will not be 0. So I have to find some condition that sine of alpha minus n, this is equal to 0. Now then what I am doing, I am assuming this alpha is a phase. Now alpha, I am trying to relate alpha using the number of samples, because number of samples is known to me. Then I am assuming that alpha equal to n minus 1 by 2. This is one particular case, alpha equal to n minus 1 by 2. If alpha equal to n minus 1 by 2, then this will become, I am starting with this expression hn equal to this alpha equal to n minus 1 by 2. Then n minus 1 minus 2n by 2. Then I can write n minus 1 minus n from this. N minus 1 minus 2n, then I am writing n minus 1 minus n. Then I am writing n minus 1 minus n, that is equal to n. So if this is equal to n, then this becomes n minus n, this becomes 0. Agreed?
Yes.
Therefore, what I can write, this equal to alpha equal to n minus 1 by 2 and n equal to n minus 1 by n, these two things together satisfying this equation. Because alpha equal to n minus 1 by 2 and this condition n equal to n minus 1 minus n, this together, if I apply, then this part become 0 and this part becomes 0, then this product will be 0, this equation gets satisfied. This equation essentially derived on the basis of two concepts. One is finite nature of the equation and also linear phase is assumed here. Linear phase is assumed here, is not it? If it is assumed, then this would be the equation. Now if this condition
স্যার বলছিলাম যে এখানে না hn into sin of n minus 1 minus n by 2 equal to স্যার 0 লেখা আছে, এটা কি করে হলো মনে?
না, if I assume n minus 1 minus n টাকে n ধরলে
আচ্ছা
হলো,
বুঝতে পেরেছি। হ্যাঁ
এটা তার মানে কি এই দুটো কন্ডিশন যদি আমি ধরি, এই দুটো কন্ডিশনকে যদি আমি ধরি, তাহলে এই ইকুয়েশনটা স্যাটিসফাই হবে। তাহলে এই ইকুয়েশনটা স্যাটিসফাই হওয়ার মানে হলো লিনিয়ার ফেজটাও স্যাটিসফাই হলো, at the same time ফাইনাইট নেচারটাও চলে এলো। ক্লিয়ার? therefore
স্যার আলফার ভ্যালুটা অন্য কিছু নিয়ে করা যায়?
হ্যাঁ
অবশ্যই।
স্যার আলফা ভ্যালুটা ডাইরেক্ট n, যদি স্মল n নেওয়া হয় তাহলে তো 0 আসছে, তাহলে ওটা নেওয়া
স্মল n ধরলে আলফা ভ্যালুটা,
ওইটা তো 0 হয়ে যাবে, সাইন এর ভ্যালুটা
আলফা ভ্যালুটা স্মল n হলো, চলো তোমার কথা ধরলো আলফা ভ্যালুটা স্মল n হলো, তাহলে এই আলফা যেটা আমার লিনিয়ার ফেজ, সেটা নাম্বার অফ স্যাম্পলের সঙ্গে কিভাবে ইকুয়েট হবে? আমাকে তো নাম্বার, আমার তো আলফাটা তো আমার নোন নয়, আলফাটা আমাকে একটা ইকুয়েশনের মধ্যে বার করতে হবে, কিন্তু আমার কাছে নোন প্যারামিটারটা কি, কতগুলো স্যাম্পল নিয়ে ডিজাইন করতে হবে সেইটা আমার নোন, তাহলে সামহাও তো আমাকে কোনোভাবে রিলেট করতে হবে। Again, one important thing I am mentioning now, this is not the only condition. You may have several other conditions by which this equation gets satisfied. However, what you have to do, that alpha has to be equated or related with some known parameter. So what is the known parameter? Number of sample is a known parameter.
Yes, sir.
Are you following? If I say,
Yes, sir.
if I can derive many other conditions, this equation have infinite solution in reality. In mathematical point of view, if you look into the equation, this equation has infinite solutions. But those solutions those solutions usable for designing a filter for practical design, those which are related with some practical parameters. Now a design parameter is given n equal to say 10. So this is my known parameter. We have to design filter with 10 samples, a FIRE filter. Therefore, a known parameter I am trying to relate to. Agreed?
Yes, sir.
Fine.
Yes.
Now, once we have understood this, then next thing that I am saying that this is the relation alpha equal to n minus 1 by 2 and hn equal to h of n minus 1 minus n. This will ensure linear phase characteristics. Now, next what we want to look into, suppose n equal to 5 and n is odd. Then what will be hn? Hn will be h0, hn will be h0, h1, h2, h3, h4. Agreed?
Yes, sir.
Now,
Yes, sir.
h of e power j omega, h of e power j omega, that will be n equal to 0 to 4 because n minus 1, h of n e power minus j omega. Now, if I write this h0, h1, h2, h3, h4, this will be the Fourier transform. So, h0 and this. Now, I have to assume this symmetric impulse response. Now, unless we here, what is the phase? Different component having different phase. With this expression, you don't have a linear phase characteristics. In this expression, you don't have any linear phase characteristic because this has a phase 0, this has a phase omega, this has a phase 2 omega, this has a phase 3 omega. In this expression, there is no linear phase because different component, different frequency component having different phase. Frequency component corresponds to this. This is a frequency domain, right? This is a frequency domain, and different frequency component has different frequency, right?
Yes.
Now I have to make this a linear phase. I will assume this h of n minus 1 minus n equal to h of 4 minus n. Agreed?
Yes, sir.
Now h0
Yes.
equal to h4, h1 equal to h3, h2 equal to h2. Then if I simplify, e power minus j omega n minus 1 by 2. This is what I know. E power minus j omega n minus 1 by 2 equal to e power minus j2 omega. Now I have taken e power minus j2 omega. E power minus j2 omega I have taken outside. Then I can write what? h0, h0 te kichu nahi. Tale h0 into e power j2 omega, h1 into e power j omega, h2. I will get, shall I get this expression if I take e power minus j2 omega common in these two? From this, if I take e power j2 omega common, minus 2 omega, then this will be like this.
Yes.
Agreed? So this is equal to h2 to h1 cos omega to h of 0 cos 2 omega. Right? What is the amplitude of this? Amplitude is this thing. h2 to h1 cos omega. This is the amplitude now becomes. Right? Now, if we put omega equal to 0, omega equal to 0 means this is 1. This is equal to 1. This is equal to 1. Some value h2 plus 2 h1, some value. Right? h2 will be some value. 1, 2, 3, 4, some value. So, some constant amplitude. And the phase becomes j2 omega means 0. So, phase is 0. Now, similarly, if for other values of omega, cos 2 omega, you will get certain value, cos omega, you will get certain value. So, this will be some value, and this phase will be correspondingly omega value, what in depending on the value of omega, phase will be 2 omega. So, entire expression having the phase minus 2 omega. Agreed? Well, once I have imposed the condition alpha equal to n minus 1 by 2, because your phase is what? Phase equal to e power j omega alpha. If you look at this expression.
Yes. Then e power minus j omega.
e minus.
E to the power minus j omega alpha. What is the phase? Phase was e power minus alpha omega. If I assume alpha equal to n minus 1 by 2, n minus 1 by 2 means 5 minus 1 by 2. 5 minus 1 by 2 minus 4 by 2. 4 by 2 minus 2. So like that. So with this assumption, I have made a linear phase characteristics of the entire expression, or entire expression means entire frequency domain characteristics. Because if you evaluate this will become constant or some value which is the value, and this phase will be 2 omega. So phase is now become constant. Okay. Now what I am saying, if I want to write a general form of this, then how this will look like? General form, how do you write this? Shall I write this h of n minus 1 by 2? And for n, suppose n may not be equal to 5 always, na? N may be 7
Yes.
also, n may be 9 also, n may be 11 also, whatever be the ln. So odd. Another important thing, if I write h of n equal to h of n minus 1 minus n, this is called symmetric. This is called symmetric response. H of n equal to h of n minus 1 minus n. If I assume this is known as symmetric condition, which is the symmetric condition. Now, if n equal to odd and this symmetric condition also exists, then only I will get this expression from n equal to 5. Agreed? Now, if n equal to 5, if I put n equal to 5, then how much it is? 5 minus 1 by 2 equal to h2. h2, n equal to 5. So h2 is matching with this expression. h2 is matching with this expression. h2 is matching with this expression. Acha. Now, next is h n equal to 1 to n minus 1 by 2. N minus 1 by 2 means it is 2.
Yes, sir.
I'm at 2. তাহলে 2. Fine. আচ্ছা, তাহলে এটা হচ্ছে 2 times h of n minus 1 by 2 minus 1. নাহলে n minus 1 by 2 টার ভ্যালু কত হবে? 2.
2 minus
2 minus 1 মানে h of 1 cos of omega.
yes.
তাহলে এটা হলো,
হ্যাঁ।
এই টার্মটা হলো। আর n equal to 2 হবে, তো 2 minus 2 মানে 0, h of 0 cos of 2 omega হলো। আচ্ছা, এবার ফেজটা কত হবে? e power j omega n minus 2 e to the power minus j 2 omega। তাহলে this is the general expression for odd number of filter samples and symmetric about h of n equal to h of n minus 1 minus n. So if the symmetric condition exists, h of n equal to h of n minus 1 minus n, and n is odd, then in general this will be the filter response in frequency domain. Filter frequency domain expression. Response we have to calculate for different value of omega, but this will be the general expression. Agreed?
Yes.
Yes.
Discuss another important thing which I forgot to tell. If you look at these number of samples, if you see 5. Now this, if you look at the number of samples, n minus 1 by 2. N minus 1 by 2 means what? 2. If n equal to 5.
Yes, sir.
Yes, sir.
With respect to 2, if you look at, this is symmetric. Because symmetric, what I understand, with respect to 2, left hand side there is 2 sample, right hand side also there is 2 sample. So with respect to n minus 1 by 2, the impulse response is symmetric. What essentially I am saying, the symmetric response, it means actually that with respect to n minus 1 by 2, the impulse response is symmetric, which means the left hand side of the 2 and right hand side of the 2, we have equal number of non-zero samples. Agreed?
Yes,
স্যার
sir.
অ্যামপ্লিটিউড ইকুয়াল না হলেও হবে, মানে
অ্যামপ্লিটিউড ইকুয়াল না হলে হবে। অ্যামপ্লিটিউড ইকুয়ালটা প্র্যাকটিক্যালি হবে না, ঠিক আছে? থিওরিটিক্যালি হতে পারে, প্র্যাকটিক্যালি অ্যামপ্লিটিউডটা ইকুয়াল হবে না, বুঝলে? অ্যামপ্লিটিউড ইকুয়াল না হলেও হবে, কিন্তু যেটা সিমেট্রিক হওয়ার জন্য দরকার সেটা হচ্ছে কি, যে একটা সার্টেন পয়েন্টের বাঁ দিক বা ডান দিকে ইকুয়াল নাম্বার অফ স্যাম্পল থাকতে হবে, তা নাহলে সিমেট্রিক বলা যাবে না। বুঝা গেল?
Yes.
Now we'll come to, and not only that, the n minus 1 by 2, n minus 1 by 2 basically alpha, na? And this alpha
Yes, sir.
is multiplied with omega, and this alpha is not necessarily an integer, What I am trying to mention that if I talk of omega is varying 0 to 2 pi, but this omega is not integer. Omega is not integer because omega could be 0 to 2 pi, means omega could be pi by 2. Pi by 2 is not an integer. Omega could be 3 pi by 2. This is not an integer. Omega could be pi by 4. This is not an integer. Therefore, I have said that DTFT is a continuous function of omega. DTFT is a continuous function of omega. This is the basic understanding you have to remember always, so that you can not have any confusion. So DTFT, if I talk of h of e power j omega or x of e power j omega, they are a continuous function of omega, and this omega can take any value, integer, omega could be real number, so in omega can take any value. So this alpha also can take any value. Alpha is essentially n minus 1 by 2. This alpha is multiplied with omega. Therefore, if omega can take any value, alpha also can take any value. Therefore, both are real number. So n minus 1 by 2 not necessarily an integer. It could be a fraction as well. It may be 2.5, it may be 3.5, not an issue. However, if I say it is symmetric with respect to n minus 1 by 2, so whether it is integer or real number does not matter. With respect to that particular point, left hand side and right hand side should be equal. Equal means equal number of samples. Then only I can say it is symmetric with respect to n minus 1 by 2. Agreed?
Yes.
Fine. So this is one example I have seen. Then we will see another example in which this is odd and symmetric. This is odd and symmetric. We have discussed, right? So now even and symmetric. I am having 4 minutes. Anyway, let us try. So even and symmetric. Again, n equal to 6 and hn equal to n minus 1 minus n. This condition is, again, I am saying symmetric condition. Symmetric condition, I will justify later what is symmetric. That is also symmetric about n minus 1 by 2. We'll see later on. Let us see n equal to 6. N equal to 6 if I talk about, then hn equal to h0, h1, h2, h3, h4, h5. Agreed? Then if I write the expression h of e power j omega, h0, h1, h2, h3, h4, h5. Again, all these different component having different phase. Now I am assuming this condition, hn equal to 6 minus 1 minus n. Then hn equal to h of 5 minus n. So h0 equal to h5, h1 equal to h4, and h2 equal to h3. Do you agree with that? N equal to 0, n equal to 1, n equal to 2 if you put n equal to 2, so h2 equal to 2 equal to 5 minus 3, so h2 equal to h3. Then what I am doing, I am writing again this. Now again, if I find n minus 1 by 2, so n minus 1 by 2 is how much? N equal to 6. 6 minus 1 by 2 means 5 by 2. So e to the power n minus 1 by 2, so alpha equal to n minus 1 by 2, I am written j 5 minus 5 by 2 into omega. Okay? তাহলে h0 if I write e power minus j 5 by 2 into omega, তাহলে h0 টা কত হবে? h0 equal to h0 into e to the power j 5 omega by 2 into e power minus j 5 omega by 2, because h0 equal to h5. If you take h0 h5 is same, then it will be j 5 omega by 2 plus j minus 5 omega by 2. Is it all right?
Yes, sir.
Yes.
Okay, so because h0 equal to h5, যেখানে যেখানে দেখো এটার মাথায় আমি ক্রস দিয়েছি, এটার মাথায় ক্রস দিয়েছি, মানে I am coupling these two. So if h0 equal to h5 means I have taken common h0. Now if I t power minus j 5 omega by 2, so it will be e power j 5 omega by 2 for h0. For h5 it will be minus j5, because minus j 5 omega by 2 minus j 5 omega by 2, that will be equal to j 5 omega. Agreed?
Yes, sir.
Similarly, if I take common h1 and e power minus j 5 omega by 2, so it will be e to the power j3 omega by 2 into e power minus j omega by 2, because h4 equal to h1, h4 equal to h1. So for this particular part, if I take common minus 5 omega by 2, so it will be 3 omega by 2. Is not it?
Yes.
এইটা দেখো, এইটার এটা যদি মাল্টিপ্লাই করো, তাহলে যে 3 ওমেগা মাইনাস 5 ওমেগা, তাহলে এটা হলো মাইনাস হবে মাইনাস ওমেগা বাই 2 ওমেগা বাই 2, সো মাইনাস ওমেগা। তাহলে এই এক্সপ্রেশন, তাহলে এই টার্মটা করেসপন্ডস টু দিস টার্ম, আর h1 ইকুয়াল টু h4, সো এটা তাহলে এখানে কত হচ্ছে 4 ওমেগা, আর এখানে 5 ওমেগা বাই 2, সো ইট উইল বি গিভিং ইউ 3 ওমেগা বাই 2, because 5 বা minus 5 omega minus 3 omega minus 4 omega minus 8 omega by 2, this is equal to 4 omega. So h1 equal to h4. Agreed?
Yes.
Similarly, h2 টা হবে. Agreed? So আমার মনে হয় আজকে I can stop here because I am having less than 1 minute. Okay, so I'll discuss these things later tomorrow. Tomorrow means Tuesday. Okay.
Tuesday.
So this up to this, because I am having less than 1 minute, so I want to stop. So I hope whatever I have discussed so far you have understood, right?
Yes, sir.
Right. Okay, so I will continue from here in the next class because I am having less than